This lesson is going to be about simplifying trig expressions. Something that's not very difficult as long as you are keeping track of each term and how to rewrite it correctly. So I'll write down some steps first. The first thing you want to do is you want to rewrite any terms in the terms of sine and cosine. Everything can be rewritten, all the trig expressions, in terms of sine and cosine. The next thing you want to do is cancel any like terms. And remember, when you cancel, you can only cancel diagonally. So if I had cosine theta over 1 times 1 over cosine theta, I can cancel my cosine thetas diagonally. Or you can cancel vertically, up and down. If I had sine squared x over sine x, I can cancel one of my sines. And then the last thing you want to do is simplify. Meaning, if you had something like cosine x over sine x, I don't want to leave that as my answer because I can't cancel anything else. I can simplify it and say cosine x over sine x is cotangent x. Your goal always is to get one term, or sometimes you're going to have more than one, but your goal is to get one term. There are a couple of things that you need to remember. The first one is tangent x or theta or whatever variable it is, a, b, is equal to sine x over cosine x. You need to know that. Another one is secant is 1 over cosine. Cosecant is 1 over sine. And cotangent is cosine over sine. Whenever you're simplifying functions, I know that secant and cosecant are reciprocals of sine and cosine. And you always want everything in terms of sine and cosine, so those two are easy. Tangent and cotangent are reciprocals, but you never want to write cotangent in terms of tangent, because you always want to rewrite tangent in terms of sine and cosine, and you also want to write cotangent in terms of sine and cosine. Your goal when you're simplifying is always turn everything into terms of sine and cosine. That's the easiest way to make sure you're doing it correctly. So now we'll do a couple examples. Okay, so the first one we're going to do is tangent x times cosine x divided by cosecant x. So the first thing I want to do is rewrite everything in terms of sine and cosine. So I know tangent is sine x over cosine x. And whatever variable they have in the equation, or in the expression, is the expression or the variable you use. So tangent x is sine x over cosine x times cosine x. And it's not over anything because it's just cosine, so it's over 1. Divided by cosecant x is 1 over sine x. So now I want to cancel anything I can. So I can cancel diagonally. So cosine x and cosine x cancel. So in my numerator, I end up with sine x over 1. And in my denominator, I end up with 1 over sine x. Now I have a fraction divided by a fraction, so I have to simplify that. Whenever you have a fraction divided by a fraction, if you remember from middle school, you keep the first, or copy the first. So sine x over 1. Change to multiplication instead of division. And then you flip the second one. So instead of 1 over sine x, I end up with sine x over 1. So now I need to multiply across. Whenever you have fractions, you have to multiply across. So sine x times sine x is sine x squared divided by 1. So I just end up with sine squared x is the shorthand for sine x squared, that quantity squared. It can be rewritten as sine squared x. These two things are the same. Because I have two sines and two x's, I have sine x all squared. And then sine squared x is a shorthand for it. For whatever reason, that's why they wrote it like that. To differentiate between sine squared all, or sine x all squared, and sine x squared. Because these two, sine x squared is not the same as sine x in parentheses squared. So that's why they put the squared after the sine, to signify that sine x all squared instead of sine x squared, because in this one the x is only squared. You do not have to write that part down. We'll just get rid of it. Okay, the next one is sine theta times secant theta times cotangent theta. So now I have a theta instead of an x. It doesn't really matter what the variable is as long as you keep consistent with the problem, because any variable is represented in an angle in the trig functions. So I want to rewrite everything in terms of sine or cosine. So sine's going to stay sine. Secant, I know, is the reciprocal of cosine, so it's 1 over cosine of theta. And then cotangent is the reciprocal of tangent. And tangent's sine over cosine, so cotangent's cosine over sine. Since I have two fractions here, I'm going to make sine a fraction as well. To make it a fraction, all I got to do is put it over 1. So now I want to cancel anything that I can. So I can cancel vertically and diagonally. So I have a cosine on the bottom, and I have a cosine on top, so I can cancel those diagonally. I also have a sine on the top and a sine on the bottom. So I end up with 1 over 1, which just gives me 1. Whenever you cancel everything, canceling, remember, leaves you a 1. It doesn't leave you 0. So I end up with 1 as my answer. Okay, the next one I have negative sine x times the quantity, because it's in parentheses, cosecant x plus cotangent x. So the first thing I want to do is rewrite everything in terms of sine and cosine. Cosecant's 1 over the sine of x. Cotangent's cosine over sine. Whenever you have one term times a quantity, remember you have to distribute. You have to distribute before you cancel, because this sine x on the outside cannot cancel with anything on the inside because you have more than one term on the inside. So when I distribute, I get negative sine x times 1 would be negative sine x. 1 times sine x would be sine x, so that's my first term. Next one, when I distribute, I get negative sine x times cosine x. So I have negative sine x times cosine x, because you can't combine them. They're two different terms, sine and cosine. And then the bottoms, 1 times sine x, I get sine x. So now I can cancel. Since I have a minus in between these two terms, I can't cancel diagonally, but I can cancel vertically in each term individually. So sine x and sine x are going to cancel, leaving me with the first term of negative 1. The second one, sine x and sine x's cancel, and it just leaves me with a negative cosine x. For this one, I can't do anything with that 1 minus cosine x. I can't combine them at all. So this one I end up with two terms. Okay, so I want you to try these three on your own. Negative cotangent x times sine x times cosine x. The next one, secant x times a quantity cosine x minus cotangent x. And last one, negative tangent x, or negative tangent. All of these should have the same variable. Hold on. Negative tangent theta times cosecant theta divided by secant theta. And then we'll work on this tomorrow.